In this section, we're looking at the sum of probabilities. Please remember to like and comment in order to help to boost the YouTube algorithm to share this channel with others. So, let's make a start. As it relates to the sum of probabilities, the probabilities of all possible outcomes add to 1. If we're talking about in the context of percentage, then it would be out of 100%. The probabilities, for example, of getting each number on a fair die is equal. We can see that for every die, there is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. So if we should look at that fractionally, each probability, the possibility of it happening is 1/6. Now, if we should add all the possibilities together, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 will be 6 out of 6, which gives us 1. So as it relates to calculating probabilities, we always start from the fact that all probabilities add to 1 whole. Beautiful. So we're going to now look at some examples where we're given some facts and we're asked to calculate the missing variables. So in the first example here, we're told that a box contains salt and vinegar crisp, cheese and onion crisp, and beef crisps. One of these bags of crisp is taken from the box at random. What is the probability they are beef? So if I look at my table, I can see that for salt and vinegar, I've got 2/5. Cheese and onions, I've got 4/9, and I need to work out what is beef. So because I know that probability adds all together to be 1, I can then add my salt and my vinegar and my cheese and onion together and then subtract that from the total of 1. So we're going to write first of all that we know beef is going to be equal to 1 take away the sum of 2/5 plus 4/9. A very good opportunity to practice our addition of fractions with different denominators. So first of all, we're going to go ahead and do 2/5 plus 4/9. I can see here my denominators are not the same. Therefore, I've got to find the lowest common multiple. So the lowest common multiple of 5 and 9 is 45. So if I multiply 2/5 by 9, both numerator and denominator, and multiply 4/9 by 5, I can get them now to be the same denominator. So 2 times 9 is 18, and 5 times 9 is 45, plus 5 times 4 is 20, and then our same denominator of 45. Now that they're the same, we can add them together. So I'm just going to put back my -1 here. So these two together will then give me 38/45. So essentially, I'm doing 1 take away 38/45. Now, because I know my total part is 45, instead of writing 1, I could then write it as 45 out of 45. So 45/45 is the same as 1. Makes it so much easier now to subtract 38/45 from that. So my denominator will remain the same. So let's rewrite that down. And then I'm going to do 45 take away 37, which then will give me 7. So that will be equal to 7/45. I then look for opportunities to simplify. If not possible, then I will just have to keep it like that. Also, we can check to see if our answer is correct. So I'm just going to fill my table in. 7/45. I can check if my answer is correct by adding them all together and see if I get 1. And if I do, I know for sure I am correct. Absolutely fantastic. Okay, so I'm just going to put a highlight here to show that this bit was just for the fractional bit here, just to make it clear. Absolutely fantastic. We go on to another example. We're told here that Darcy has a biased spinner. So biased means each outcome was not the same amount of chance of happening, unlike the spinner we did. So a spinner has section labeled 1, 2, 3, 4, and 5. We are asked to work out the value of x. We can see here that for 2 is 0.15, 3 0.05, 4 0.2, and 5 0.35. Again, even though this is decimal, we still know that the total of probabilities is 1. Therefore, to get x, I would then need to do 1 take away the total of 0.15 plus 0.05 plus 0.2 plus 0.35. So I'm going to get a total for that, and then I'm going to take that away from 1. So let's just put that in our calculator quickly and see what we get. So 0.15 plus 0.05 plus 0.2 plus 0.35 gives me 0.75. And then I'm subtracting that from 1. An easy way to do this, I can just look and say, if this is 100 and this is 75, then the answer will be 25. So since it's a decimal, it will now be 0.25. So therefore, x is equal to 0.25. So we've done fraction and we also have done a decimal as well. Same principle does apply. Brilliant. Now we do another example where we're told that Beatrice has a biased four-sided spinner. The table shows probability that the spinner will land on 2 and 3. However, we are given 1 and 4 blank columns. The probability, however, that the spinner lands on a 1 is 3 times the probability that it will land on a 4. So the probability the spinner lands on a 1 is 3 times the probability that it will land on a 4. So let's just write that 1 to 4 3 times. So it's going to be 3 to 1. So the probability it lands on a 1 is 3 times more than it will land on a 4. So it's going to be 3 to 1 as a ratio. So we're asked to work out the probability it will land on a 1. So I'm going to choose to do this algebraically. So that means 1 would be 3x and let the 1 4 will be x. So I need to now add all of this together and then solve it for x, and then I can work out what it is for 1. So we're going to do that 3x add 0.1 add 0.3 add x should be equal to 1. So I'm going to now collect my like terms. So I've got 3x add x, which is 4x, and I'm going to do 0.1 plus 0.3, which is 0.4, and that will equal to 1. So a beautiful opportunity here to practice rearranging the formula to make x the subject. So I'm going to do the reverse of plusing 0.4, which is subtracting from both sides. So I will have 4x left, and that's equal to 1 take away 0.4 is 0.6. Last step, we need to divide by 4 to get x on its own. So I'm just going to quickly put that in my calculator. 0.6 divided by 4, and that is equal to 0.15. So remember, that's just for 4. But we're told that 1 is 3 times greater than that. So I now need to multiply 0.15 by 3. So therefore, the chance of getting, so probability of a 1 will be equal to 0.15 multiplied by 3. So I know 15 times 3 is 45. So I should have 2 spaces of decimal. So therefore, my answer is going to be 0.45. And I could have put that on my table if I wish to do so. But essentially, I can do a rough check to see if this is correct. So 0.45 plus 0.15 is 0.6. And 0.6 plus these two, which is 0.4, does get me back to 1. Guys, a very good example, a very good practice rather, is that if we've got enough time in our exam when we get an answer to substitute it back in and to prove that the answer adds back to 1. Absolutely brilliant. Now we're going to focus on calculating probabilities. Now, to calculate probabilities, when all the outcomes are equally likely, we use the following formula. So the probability in the part 1, we talked about what notation do we use for probability, and we said it was P on the outside of a bracket and the event on the inside. So the probability of an event is equal to the number of ways an outcome can happen divided by the total possible outcomes, and we'll see that what that looks like in a few questions. So I would say pause the video, write this down. So the probability will always be equal to the number of ways your outcome can happen over the total possible outcomes. Twisted tongue right there. So let's look at it as a question. So we're calculating probabilities and we're told that Leah has 12 cards. So we underline that, each with a shape on it. She takes a card at random, means from the total. And we are asked to calculate what is the probability Leah takes a card with a star on it. So again, so possibility here will be how many stars out of the total of the cards. So there's just 1 star here, so it's going to be 1 number of outcomes, 1 out of the total possibilities, 12 cards. So the answer then is 1/12. Part B asks us what is the probability Leah takes a card with a triangle on it. So we need to look for number of triangles involved. So we got 1, 2, 3, 4, 5 triangles. And that's going to be out of the total again, which is 12. 5 12s cannot be simplified. So I'm going to have to leave my answer like that. And then I've got C. What is the probability Leah takes a card with a circle? So circle 1, 2, 3, 4, 5, 6 circles. So 6 is the total outcome out of all possibilities now, which is 12. This now is 6/12, which also can be simplified to a half. We always try to simplify fractions to the lowest possible terms. Some questions specifically tell us to do that, others do not. Now, if the question doesn't tell you and you're not so good at simplification, then you should leave it as the first answer. However, it's good to practice because some questions do specifically state give your answer in the simplest form. Beautiful. So we need to know our timetables. So now we're going to do this question that will have a little bit more calculation, and then we will do one question more and then we are finished. So we're told here that Evelyn has 80 pens in a drawer, underline. 15 pens are black, so black is 15, and the other pens are blue. So Evelyn picks a pen at random from the drawer. What is the probability that Evelyn picks a black pen? So straight away we can write this fraction down because we know that blacks are 15. So for part A, we've got 15 and the total is 80. So 15 80ths, again, that can be simplified. So what number goes into 15 and into 80? And the answer is 5. So 5 into 15 goes 3 times, and 5 into 80 goes 16 times. 16 times 5 is 80. Beautiful. So question part B asks us what is the probability Evelyn picks a blue pen. So I knew that there were 15 blacks and there was only black and blue in the bag. So I got to do 80, take away 15, so that I can get what is my numerator going to be. So 80 take away 15 will leave us with 65. So therefore, I can write it's going to be 65 80ths. And again, I can simplify. So what number goes into 65 and into 80? That's 5. How many 5s are in 65? And that's 13. Yes, it's very good to know your timetables even beyond the 12 times. And then again, we also have done 5 into 80, which was 5 into 80, sorry, which was 16. Now we've got 13 16ths, cannot be further simplified, so we leave our answer. So one was 3 16, the other was 13 16ths. Beautiful. Now guys, we're going to do our final question and then we will summarize. So I've got, there are 20 counters in a bag. 2 are white, so I like to write things out. So I've got white is 2, 1 is pink, so pink is 1, and 4 counters are black, so black is equal to 4. The rest of the counters are purple, so let's put purple and then we'll work towards what that is. This question is different because it says Carter takes a counter at the back out from the bag at random. It says show that the probability of the counter will be white or purple is 3/4. So white or purple, or in probability, means that we are adding them together. So we've got to work out, first of all, since we do not know how many purple, we got to work out how many purple, and then we'll be able to add white and purple and see that we get 3/4. So I know there are 20 counters in the bag, so purple then has to be equal to 20, take away 2, add 1, add 4. So those are the counters that we already know, white, pink, and blue. So and black, so let's add those together. So we got 2 plus 4 plus 1, that's 7. So 20 take away 7 is 13. So there are 13 purple ones. So now we can work out the probability of white or purple, and that means to add them together. So white is 2 of 20, so white plus purple. So 2 20ths for white and 13 purples, so 13 20ths. Okay, so now we're going to add these together. 2 plus 13 is 15, and common denominator, that's why we could do that. Now we got 15 20ths, so this is a question that relies on simplifying our fractions here. So 5 goes into 15 3 times, and 5 into 20 goes 4 times. So there we have proven that the probability of the counter being white or purple is indeed 3/4. See, simplification in this question will now have been necessary to prove the answer. We couldn't have left it as 15 20ths, else we would not have proven it. So that's why it's important to simplify where possible. Absolutely brilliant. So guys, remember, we are going to be going on to our in the next video, we're going to be looking at section 3, which is going to be on listing outcomes and sample space diagrams. Make sure that you guys, if you haven't done so yet, you have hit all so that you can get the notification when part 3 is uploaded as well. Share, tell a friend to tell a friend. Remember, we are on TikTok. New questions have come out on TikTok. By the time you get this video, the new videos will be on TikTok as well. Make sure that you engage, leave a comment, hit the like button, and help the YouTube algorithm to share it with other potential users. Until the next upload, guys, thank you so much for watching.